Well, let's take a look at another example of adjustments in this line measurement example. And we're given 4 points on the line, A, B, C, and D. And we want to figure out the value of AB adjusted, AC adjusted, and AD adjusted. Given 6 measurements, AB, BC, CD, AC, BD, and AD. So these are the 6 given measurements. And from this, we need to determine AB adjusted, AC adjusted, and AD adjusted. So that means there are 6 measurements with 3 unknowns. And there are 3 redundant measurements, since 3 measurements would be necessary to determine for a unique solution. So now we have to write down our 6 measurements. We have to write down 6 equations, write down the measurements as a function of the unknowns. And these are our 6 measurements. AB adjusted theoretically where AB is equal theoretically to AB adjusted. That is the measured as a function of the unknown. BC is going to be equal to, what's BC going to be equal to? BC given the as a function of the unknown is going to be AC adjusted minus AB adjusted. So AC minus AB is going to be equal to BC. CD is going to be the difference between AD and AC. AC as the measured value, theoretically as a function of the unknown, is going to be equal to AC adjusted. BD is AD minus AB. And AD theoretically is equal to AD adjusted. And again, all of these implicitly contain the residuals. That is, we can add plus VAB plus VBC plus VCD plus VAC plus VBD plus VAD. So now we've written down the 6 measured as a function of the unknowns. We can separate them into knowns, and we can separate them into one side into the knowns, the other side into the unknowns. This side, the right side, is going to be our known values, and the left side is going to contain our unknown values. So our y vector is going to be the vector of the knowns. It's just going to be our measured values, AB, BC, CD, AC, BD, and AD. Our x vector is our vector of the unknowns, and that's going to be AB adjusted, AC adjusted, and AD adjusted. And again, personally, I don't like to write out the residuals, but if you want to, you can write out the residuals. But even if they're not written out, just keep in mind, since this is least squares adjustment the results are never going to be exactly perfect, but there's always going to be a residual. And what's a residual? A residual is the difference between the measured value and the adjusted value. So once we have our equations and once we have separated them into knowns and unknowns, we can write down our Jacobian matrix, that is the partials with respect to the unknown based on our equations. And we have to write down the partials in the same order as our vector of the unknowns. That is the partial with respect to AB adjusted, AC adjusted, and AD adjusted. So this order has to match this order. So in our first equation, there's no AC adjusted, there's no AD adjusted, there's only AB adjusted. The partial with respect to AB adjusted with respect to AB adjusted is just 1. For the second equation, we have a minus AB adjusted, so that's minus 1, and AC adjusted, that's 1. There's no AD adjusted. So for the third one, it's going to be minus 1 with respect to AC adjusted and 1 with respect to AD adjusted. There's just AC adjusted in the fourth one, a minus AB and a plus AD adjusted and an AD adjusted. Then calculate the adjusted values. In the vector of the unknowns, it's going to be in the same order as this. A transpose A inverse A transpose Y. The P inverse is the inverse command, or the pseudo inverse command. And the pseudo inverse command works when there's a great difference between the it's a generic inverse command, but it can be used when there's a big difference between the values of the Jacobian matrix. Say one value is 1 over 1 million, and another value is a million. So there's a million times a million magnitude difference between the two values, and sometimes that can become unstable, so that's why the P inverse command can be used. But you can use the exponential to the minus 1 if you like that. The apostrophe is the transpose. Then calculate the residuals, and here's an adjustment check if this is a small number. V transpose times V plus this. This is just kind of a FYI, and let's see how this works. So I'll download this. So there's our program, and let's run it. Oh, this should be just a comment. So there are our measured values. There's the y vector, which is just basically the measured values, our A matrix. There are the adjusted values in the same order. In this order, so this is AB, AC, and AD adjusted. Those are our residuals. That's the difference between the measured and the adjusted. And it's A times X minus Y. Our adjustment check is a small value, and let's take a look at the sums of the squares of the residuals, which is V transpose times V, and that's also a very small number. So it looks like we figured out the correct adjusted values. So this is the measured AB, that's the this is the adjusted AB, so there's a small difference between the two. Measured AC is 400, and measured AD 599.99, 599. Or this is the adjusted AD, and that's the measured AD.